Alright, so here we are again. I have another question to look at. My thinking is pretty much to just kind of keep solving problems and kind of split them up. Each video will be about each problem. So yeah, that last problem looked like it also could have been 10-15 minutes, but I don't know, man. I indulged. The last problem could have been fast. The problem before that could have been fast, but well, don't always know, what the limitations are, how quickly you have to solve them. The absolute optimal is like kind of hard to see sometimes, I guess, but sufficient is sometimes not too bad. So the idea now is basically we'll just look at the next problem and see. Maybe we'll try to do it quicker this time. See how we do. So let's give it a shot. Yes. Alright, so here we are. Shortest word distance 3, so this should be similar to the last problem. It should be similar. You get to watch me freaking have my face pressed up against the monitor because I'm blind. But given the list of words in 2 words, word 1 and word 2, return the shortest distance between these 2 words in the list. Word 1 and word 2 may be the same, and they may represent 2 individual words in the list. Assume that the words practice makes perfect coding, makes word 1 makes word 2 coding, output 1 makes word 1 word 2. You may assume word 1 and word 2 are both in the list. So this is very similar to the previous question, however, this time around we're not querying the same list multiple times. This time around we just have one time that we just have one time. We're given the list of words and we're given 2 words as parameters. So we don't have this luxury that we had before. Now this is very interesting. Well, I mean, obviously we could do this in linear time. It's a little, yeah, this is a little more challenging. I'm actually not sure about this one. A few things to say about it. So, all the thoughts that I was having before, I guess you'd want to reapply them here. The problem here, though, is a lot of it changes. Like a lot of it's not applicable. So one of the things that's really difficult initially is that just figuring out what the index for each word is in the list in the first place, what the set of indices even, would require you to loop through the entire list twice to do both. Now you can collect these indices, but in theory, I mean, I could write literally the same algorithm that I wrote before, where you collect the indices for word 1, collect the indices for word 2, and then loop through both sets of indices to find the answer. Now the question is that going to be fast enough to solve the problem? We could just code it, submit it, and see if it's fast enough, and then go from there. Let's do that, because I kind of don't want to take forever to try to solve this problem. As we did last time, it was like it kind of takes forever. It kind of takes a long time, so I want to try to be a little bit faster. So this time around, we're going to use 2 vectors. Make sure I spelled it correctly. and we're gonna say just indices 1, indices 2. Yeah, okay. And we're going to say for int I equals 0, I is less than. We can also modify this. This is a const. Oops. Right. You can modify all of these. Hopefully I can do this without looking. Say I is less than words dot size string words of I. Say if W equals word 1, and we say edge case. Oh, yeah. By the way, if we just say word 1 equals word 2, we could just return 0 immediately. Right? Oh, they may be the same and they represent 2 individual words in the list. Oh, that's very interesting. Oh, no kidding. Wow. I'll actually handle that separately then. Oops. So if W equals word 1, then we say indices 1 dot push back I. If W equals word 2, indices 2 dot push back I. And now we say, do something special, otherwise we say for auto X in indices 1, for auto Y in indices 2. Not max, but max. And let's say ret equals standard min of ret of standard absolute value of X minus Y. Right? And then return ret. So pretty brute force here. And obviously there's this one edge case. If they're the same word, then you actually want to, these will be sorted to begin with, by the way, so you don't need to sort these. In that case, you can really just take the differences over just this index set, indices set. But I mean, it really doesn't matter, I guess. Actually, now I think about it, you could really still just do both. Oh, I don't know. The only time we get 0 is See, actually, you don't even need to do that either. Take that back. Forget the edge case. You can handle the edge case directly. Yeah, you can just do it this way. That should work too. Yeah, okay. Do we just go for it? I kind of wanted to try some test cases. Let's at least try the second test, or the couple of test cases. Makes. And then we'll try. Actually, that was the other test case I wanted to check. All right, let's go for it. Done. All right, sweet. Okay, great. See how much faster that is? See how much faster that is? How long did that take us? How long did that take us? 11 minutes. All right, perfect. Keep it simple, stupid, right? All right. We'll close this one here and go on to the next one. Close this one here and go on to the next one. Where's the button? Yeah, here we go. Here we go. So.